So, this lesson, we're looking at the last bit about chapter 2, which is about solving modulus problem. Previously, you've learned about combination of transformation. You've learned how to solve modulus equations. You've learned how to sketch graphs, transformation, all that kind of stuff. Today, we're just looking into various questions related to modulus. So it's like a mixed sort of final topic, a bit of lesson, just to wrap up everything, I guess. Including a little bit of problem solving you will see in the exam as well. So let's have a look. So example number 1, given the function, this time it's called t of x, not f, t of x is 3, the modulus x minus 1 minus 2, where x belongs to whole real numbers. So remember, this means x can be all real numbers. X can be all real numbers. So that is a Greek letter standing for the set of all real numbers. Sketch a graph of the function. Now, what you have to understand first of all here is this is actually a linear equation because it's still in mx plus c. The x is still in the power of 1, but you've got just different bits and pieces around here. So we call the parent function. Let's say we call it parent function, which is the original. I'm not going to use t. Let's use f. Okay, so f of x. The original will be the graph of modulus of x. If we cut down all the fluff, all the other things, then down to its own, the function is just modulus of x. So then the rest of them is just a transformation. It's like there's the pasta, and then you put everything else. They are just the ingredients. They are just the sauce, etc. So but down to its own, it's just a pasta modulus x. So let's have a look one by one. We have a minus 1 there. So f of x minus 1, that's x minus 1. And then we multiply 3 outside. So 3 f of x minus 1. That means 3x minus 1. And then with minus 2 outside, so 3x minus 1 minus 2, which equals 3x minus 1 minus 2. Okay. So you can see there are how many transformations? 3. 1, 2, 3. So from the modulus of x graph, we know the modulus of x graph looks like this. Now that's y equals x. Therefore, the modulus of x graph looks like this. Okay, so that's the modulus of x graph. Then what you have to do in here is you have to move left and move right by 1, move right by 1, and then you will have to stretch in y by 3, and then you have to move down by 2. Okay, so that's what you do. So you can do it one by one. I would suggest you try it on your own. See if you can try to transform this modulus x graph into the final one. I'll show you the answer. So the final answer, you can pause the video now. The final answer, so let me draw a straight line. So that's the final answer would be like this. That's what I've got. And that number here will be 1, and that number here will be minus 2. Yep. Okay. So that's the final answer. That's the t of x graph. Part B. State the range of the function. The range, now if you draw a graph, the range will be easier because you can see the range means the y value. Remember, domain and range, D comes before R, so does X come before Y. So range is about the Y value. So we can see the range of values go from here all the way up. So the range is Y, or we can say T of X is greater or equal to minus 2. Right, part C. Solve the equation where t of x equals a half x plus 3, half x plus 3. So 3 modulus x minus 1 minus 2 equals half x plus 3. As we know, to solve modulus equation, we will have to make in 2 separate scenarios. One is when we turn the modulus into just a normal bracket. And the other one is when we have to change the modulus into a negative bracket. So negative 3 bracket x minus 1 minus 2 equal half x plus 3. So let's solve the left one. Expand the bracket normally. 3x minus 3 minus 2 equals half x plus 3. Half x bring to left becomes a minus. 3 take away half is 2.5x. Minus 5, that one will be 8. And then x here, if you divide that, it will be 3.2. For the right one, expand the bracket, it'll be negative 3x plus 3 minus 2 equals half x plus 3. This time, bring the minus 3 right-hand side, becomes a plus of 3.5x. 3 minus 2 is 1, minus 3 is minus 2. So if you divide that, x equals minus 4 over 7. So we've got two answers, and we've solved it. These are the answers. Okay. Any more? That's it. Example number 1. Practice. Have a go at the question. They ask you to sketch a graph of each function and state the range. Both of them, I'll give you a bit of hint. You start with f of x. The parent function is modulus x. By the way, the parent function means the original, the OG parent function. F of x equals modulus of x. The rest of the fluff numbers is just a transformation. Have a look. If you struggle with it, have a look in the previous one, how I go from transformation to transformation. You can try to follow it and have a go. When you're ready for the answer, you can press play. Right, so for part C, the answer will look like this. That's 4, that's minus 2. Okay, and part D, the answer will look like so minus 1.6, 1.6, or 8 over 5. That would be 4. Okay. Right. So let's move on. Example number 2. The function f is defined by f of x equal. So let me rewrite this. A function f of x equals 6 minus 2 modulus x plus 3. A sketch of the graph of the function is sketched in the diagram next to it. State the range of f. So you can see in diagram, the range, again, range is about the y value. So you can see the range is from here all the way down there. So the question is, what is that? What is this y value? If we know the y value of that point, of that tip there, then we know the range, because the range will be whatever with y less than or equal to that number of y. So the question is, what is the value of y? Now, that special point is the maximum value. So this point is the maximum value. Now, maximum value, normally you'll be thinking about differentiation. However, this is not the case, because this is about modulus equation. The differentiate doesn't quite work for linear equation. So we think about what's the maximum value in here. So we can look into the equation, think about the numbers. Now, let me ask you a question. What is the lowest value you can come up from a modulus expression? For example, what is the smallest, let's say, of modulus x? What is the smallest value that you can get out of modulus x? Imagine x could be any number. What is the smallest you can get? The answer will be 0. The minimum, or the minimum will be 0. So the minimum of any modulus will be 0. Even if you do f of x equals, let's say, x plus 2, the minimum you can get out of this whole modulus is 0. Because if you put x is minus 2 in there, minus 2 plus 2 gives you 0. If you put any number bigger than or smaller than minus 2, let's say if you put 3 in there, you'll get 5. If you put minus 3 plus 2 is minus 1. But because of the modulus, you make a 1, which is bigger than 0. So what I'm trying to get in here to tell you is, in this modulus thing has a minimum value of 0. Now, to find a maximum value of this function, to find the overall maximum, because there's a negative minus in there, you want to make this as small as possible. I'll say again, to maximize the whole thing, you need to minimize this. Because if you try to make it bigger, 6 to a bigger number will make the overall number smaller. So to maximize f of x, which is what we're trying to find here, the maximum value, we need to minimize this. And to minimize this, we can only, this modulus thing will go only as low as 0. So therefore, the max f of x, the max value of f of x, or you can remember f of x could be replaced by y. So max value of y equals 6 minus 2 times 0, which is 6. In other words, that tip has a y coordinate of 6. And therefore, the range is f of x less than or equal to 6. Part B, give a reason why inverse of f of 1 does not exist. Now, from this graph, we can tell this is so f of x is a many to one function. If you forget what's a many to one function, think of it like a quadratic, like a U shape. Like a U shape. This is called a many to one function because many x, many means more than one, give the same value of y. Same with this one. When x is minus 6 and 0, it gives y 0. This value will give the same thing. So many x to one y value, that's a many to one function. Now, but when you do the inverse, then the inverse becomes an one to many. So inverse, many to one, you flip it, becomes one to many function. Now, what's the problem with one to many function? See if you remember about 2.2. A one to many function is, which is not a one to many function, is not a mapping function. Therefore, the inverse of f of x does not exist. Okay. Well, why is a mapping function a problem? Because this f is a mapping function. You can see, remember the colon x and then this symbol arrow means this is a mapping function. So the whole premise built on this question, built on this function is a mapping function. Part C, solve the inequality f of x greater than 5. Give you a treat at the end. Wrap it up nicely. So part C, we know 6 minus 2 modulus x plus 3 is greater than 5. Anything to do with modulus, split in two cases. The first one is change the modulus into a bracket. And the other one is change it to negative bracket. So 6 minus minus becomes a plus 2 bracket x plus 3 greater than 5. And then just solve it. Remember, we divide negative numbers if we switch the symbol, the inequality sign. Sorry, my brain is not working properly. So in here, let me look at the answer. The answer would be, I couldn't find it, I'll just do it. 6 minus 2x minus 6 greater than 5. 6 minus 6, 0. So minus 2x greater than 5. So when I divide by minus 2, I have to change the sign. Less than 5 over 2, negative 5 over 2, expand bracket, 2x, 6, so 12 plus 2x greater than 5. Bring it over, 2x greater than 5 over 12. No, 5 minus 12, which is minus 7. So x greater than minus 7 over 2. So now to do this, I usually do put in decimal first because I just want to see a raw number. So that's x less than minus 2.5. That's x greater than minus 3.5. So if I do a number line, minus 2.5 is here, minus 3.5 is there. X has to be in between them. So the answer would be minus 3.5 less than x less than minus 2.5. And that will be the answer. Okay. Right, practice question. This is quite a tricky one. Have a go at the questions. Try to sketch a diagram out. Now, you don't know the value of k, but you could sort of try to sketch a diagram without k. And if you struggle, or if you want to know the answer, you can play the video, but have a go first. So two functions, m and n, are defined as this and this, where k is a constant. The equation m of x equals n and n of x has no real roots. Find the range of possible values of constant k. Now, it does give you a bit of hint on the side here. When they have no real roots, it means they don't intersect. Now, when we see the word intersect, our eyes are just focusing on the word intersect. We treat it like they intersect and make them equal. Okay, if they do not intersect, that means they have no answer at the end, but we still make them equal. So we're going to make them equal to begin with. Okay, so minus 2x plus k equals 3x minus 4 plus 6. Similar thing, two cases because of the modulus. So minus 2x plus k equals 3 bracket x minus 4 plus 6. And minus 2x plus k equals negative 3 bracket x minus 4 plus 6. Minus 2x plus k, expand the bracket, 3x minus 12 plus 6. So if I make k the subject in here, k equals to 5x minus 6. This one, if I sit with the algebra in there, you get k equal minus x plus 18. So if I try to make them equal, okay, so simultaneous equation, 5x minus 6 equals minus x plus 18. You get 6x equals 24, x equals 4. So therefore, k equals to 5 times 4 minus 6, which is 14. Right, so what it means is, now remember, they don't intersect. That. So what does this number mean then? It means when k equals 14, m of x and n of x intersect. But the problem is they don't. So there's something to do with the 14, this number 14 here. So let's have a look how we can solve the question. Now, k equals 14, that means they intersect. So m of x is 2x plus k. Let's draw a diagram here. Okay, so m equals 2x plus k. Now, if k is 14, let's say if k is 14, minus 2x plus 14 is a line that, so y-intercept is 14, so like this, that's m of x. Yes, that's m of x. Right. Now, so for n of x, let's try to draw a mini graph for n of x first. So 3x minus 4 minus 6. So originally it's like this. We move to right by 4. So that becomes this. That's 4. And then we'll move, and we're stretching y by 3. Doesn't matter. We'll move down by 6. Or plus 6. I was wondering. Plus 6 means the answer will be here. Plus 6. 6. Okay. So what it means is now because they do intersect, that means the graph has to look like this. Because otherwise they don't intersect. And what we know is that point here must be 6. And that point here is 4. Okay. Right. So that's n of x. So that's n of x. Now, the question asking, find a possible values, a range of values of k so that they don't intersect. Now, if you think about the value of k in terms of transformation, what is the role of the k in this equation of m of x? What is the role of k in terms of transforming the graph m of x? Imagine put different value of k, how would the graph move? K is the number outside 2x minus 2x. That means if you put k in there, it'll be moving up or down. So k is a value that you move up or down. Now, if you want the graph m of x and n of x do not intersect, if you want them not intersecting, how would you move the blue line so that they don't intersect? You have to move them down, don't you? Because if you move up, they will only intersect more and more twice. Yes. But if you don't want them to intersect, you have to move them down. So moving them down means the k value has to be less than 14. Because when k is 14, they intersect like this. But you want the graph to move down and down and down. Therefore, the final answer, k has to be less than 14 for m of x and n of x not intersecting. Okay, this is a particular hard question. It's a 4-mark question, but in terms of understanding, there's a lot to do. Right, so that's the end of chapter 2. Thank you for listening.